is the null, we say there's not enough evidence to reject the claim. There is not sufficient evidence to reject the claim. And then we say what the claim was. The claim was that the mean is less than or equal to 5.6. Okay, so you just got to make sure that you've got these straight. Okay. All right, what are the two types of hypotheses used in a hypothesis test and how are they related? So we kind of already talked about this, right? It's the null, right? This one is the null, and this one is the alternative, right? And they're related. They are complements of each other. We already talked about that. Okay. All right. Use the given statement to represent a claim, right? So they're saying that this thing right here is the claim. So they're saying the claim was that the mean is less than or equal to 497. Okay, so before I read anything else, well, not before I read anything else, test taking strategy, read the question first. But if this was just a homework, I might say, okay, I know what to do here. I know what to do when I have the claim. I say, okay, did they just give me a null or an alternative? That has some type of equality, so they gave me a null. I'm just going to label it, and then I'm going to write my alternative, which is the complement, which is greater than. And I know that my alternative is what I use to determine if this is one-tailed or left-tailed, right-tailed, or two-tailed. This is greater than, so this is right-tailed, right? So all of that you can do as soon as you know what the claim is. Okay, so let's see what they're actually asking us. Use the given statement to represent a claim. They gave that. Write its complement. Oh, look, we already did that. And state which is the null and which is the alternative. Oh, look, we already did that. Right? So just kind of get into the habit of just as soon as you see that, just go ahead and write this rest, the rest of this, just this part right here. Just do it all at once. Get it over with. So the complement is that it is greater than, right? So this was the claim. The complement is greater than, right? We went through that before, right? That if you have this, the complement of that is that. If you have this, its complement is that. If you have this, the complement is that. Okay. Which is the null and which is the alternative? We already know that the null is going to have some type of equality and the alternative is only going to have an inequality. So that's why it's this one, right? Okay, I see that it stopped recording for a minute and then it started recording again. I'm not really sure why it did that, so hopefully it didn't cut out a whole minute. Maybe we just lost internet here in Palm Coast for a minute. Not really sure. All right, continuing on. Okay, given the null hypothesis is this and the p-value is this, do you reject or fail to reject at this level of significance? Okay, so the null was that this is greater than 18. So what is the alternative? It's going to be that it's less than 18. So again, if I wanted to, I could draw this little picture, tell myself that's left-tailed. Okay, they're telling me, they're saying, hey, we already did a bunch of the stuff for you, right? Here's your p-value. Your your p-value is 0.074. They're telling us that our alpha, or our level of significance, is 0.05. And they're saying, based on that, are you going to reject or fail to reject the null? So it almost doesn't matter which of these was the null and which of these was the alternative. Like they didn't even necessarily need to give us that. All they really had to do was give us a p-value and an alpha, and we tell them, are we rejecting or failing to reject the null using the decision rule, right? So is the p-value greater than the alpha, or is it less than or equal to the alpha? It's greater than. So if it's greater than alpha, we fail to reject the null. So we fail to reject the null. Okay, we're in the home stretch here. Okay, test the claim about the population mean at the level of significant, at the population mean mu at the level of significance alpha. Assume that the population is normally distributed. Okay, so they're giving us a lot of information here. Let's parse it all out. Claim is that the mean is greater than 20. Okay, did they just give us a null or did they just give us an alternative? They just gave us an alternative. That was our claim. All right, so the null is going to be the complement of that. Okay. They gave us that our alpha level of significance is 0.05, and then they gave us a bunch of other information. They told us that the population standard deviation is 1.2. And then for the sample statistics, we have a sample mean of 20.3, and we have a sample size of 50. All right, so we are going to, because we have a population standard deviation, we are going to do a z-test, right, to find our p-value. Okay, so we do stat, test, z-test. We're going to input all of our information. So we have 20, we have 1.2, it's 50. Okay, so remember the number up here, and it kind of gives you a hint. It says, hey, sub-zero, right? Don't forget the number associated with your null hypothesis. That's what should go there. Right, so the first number here is the number that's associated with your null hypothesis. Okay, and then down here, you're telling it what, I mean, I didn't do this. Why didn't I do this? I always do this. This is right-tailed. I always draw the picture. I don't know why I forgot to draw it there. Okay, what goes down here is the symbol associated with your alternative hypothesis, which is a greater than symbol. Okay. All right, so it's going to spit out some information. What we're looking for is that p-value of 0.0385498886. I don't really need all those decimals because really I'm just comparing it to 0.05. I need to know if it is greater than alpha or if it is less than or equal to alpha. So is 0.03 blah, 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 blah greater than or less than 0.05? It is less than alpha, less than or equal to alpha. So we're going to reject the null. Okay, we're going to reject the null. And the other piece of information that I want to remind myself of is that my claim was which one of these, right? Claim was, and then we say, okay, which one was my claim? My claim happened to be the alternative. So we rejected the null and the claim was the alternative. So if we reject the null and the claim is the alternative, then there is enough evidence to support the claim. We rejected the null. There is enough evidence to support the claim at this particular level of significance. Right? Just gotta keep referring back to this or memorize it really. Okay, test the claim about the population mean at the level of significance alpha. Assume it's normally distributed. So same process here, right? The claim is that the mean is not equal to 42. So did they just give us a null or did they give us an alternative? They gave us an alternative here. So now that we've written that, we can write its complement, which is the null. We can remind ourselves that this is a two-tailed test. We're going to write down everything else they gave us. So they gave us that alpha is 0.05, 0.05 level of significance. We have a population standard deviation of 2.7, so we know this is going to be a z-test, and then they gave us some sample statistics, a sample mean of 41.1 and a sample size of 35. So again, we're going to do stat, tests, and then we're going to do z-test because we do have a population standard deviation. We're going to plug in everything that we know. The first thing is the number that's associated with your null hypothesis, your population standard deviation, your sample mean, your sample size, and then again, this is the symbol that's associated with your alternative hypothesis, right? Don't get confused that it's got the little null thing there. These symbols are only available to your null hypothesis. So this is a not equal to. So again, it's going to spit out a p-value for us. We have 0.0486064304. It doesn't matter, all of that. I just need enough decimal places to be able to compare it to the alpha of 0.05. So my p-value is less than or equal to my alpha. So I'm going to reject the null. Okay, so I reject the null. And you know what? I don't even have to worry about how to word it, because if I look at these options, my options are there's not enough information to decide, which is not true. We had all the information we needed. Also, we're allowed to, because this is both this is normally distributed and this is 30 or greater. It needs to be at least one of those, and it's both. So we're good on that. So that's not the right answer. As soon as we know that we're rejecting the null, we can just go ahead and select A. Now, if they had multiple options where you were rejecting your null, then yeah, you need to go ahead and take a look at this to say, well, how exactly am I supposed to be wording my answer? So let's pretend like we have lots of options just for practice, right? Reject the null. And then the other piece of information I need is which one of those was my claim? Okay, my claim was, in this case, the alternative. So we reject the null and the claim was the alternative. Reject the null, the claim is the alternative. So we can word it as there is enough evidence at this level of significance to support the claim. Reject the null, there is enough evidence at this level of significance to support the claim. Okay. Okay. 55, find the standardized test statistic T for a sample with the following information. So we have an N of 15. We have a sample mean of 6.4 and a sample standard deviation of 0.8. They're telling us that our alpha, our level of significance, is 0.05, and they're telling us that your null hypothesis is that the mean is less than or equal to 6.1. So they've given us the null. We can find the alternative, right? This tells us what kind of a test we have. This is a right-tailed test. Okay. Find the standardized test statistics. So they don't want us to solve this whole thing, so I didn't necessarily have to do all that. Let's just have it. They've specified for us that it's a t-value. If they hadn't specified a t, we would have known anyway, because we have a sample standard deviation, not a population standard deviation, right? Okay, remember, if you have a population standard deviation, it's a z-test. If you have a sample standard deviation and not a population one, you have to use the t-test. All right, so we're going to go stat, test, and we're going to go down to t-tests. We're going to plug in everything we know. Right, the number associated with our with our hypotheses is a 6.1. Sample mean is 6.4. Sample standard deviation is 0.8. Sample size is 15. They didn't specify. Well, anyway. Okay, and then the symbol associated with our alternative hypothesis is greater than, and it is going to give us the t-value. I mean, it also gave us the p-value, but it gave us the t-score of 1.45. And this time they're just asking for the t. Because remember, if you're doing this by hand, you have to find the t first, because the t is that right there, right? That's your t-value. And you use that to find the area, in this case to the right of it, and that area is your p-value. Then you can compare your p-value to your alpha. But we're not doing this by hand, right? Okay, so I know this looks like a lot, but it's really just the same type of problem that we did a couple problems ago, where we're just doing the whole problem. They're just asking you to provide them the answers kind of each step of the way. So let me get a drink first. Okay. A research center claims that 26% of adults in a certain country would travel into space on a commercial flight if they could afford it. That's my claim. Is that the proportion of US adults who would do this is 26%. Did they just give me a null, or did they just give me an alternative? That has an equal sign, so they just gave me the null. That's the claim. The alternative is a strict inequality, so I can write that. I can also remind myself that this is now a two-tailed test, always based on the alternative. Okay, what else did they give us? In a random sample of 800 adults, in that country, 28%, so my p hat is 0.28, say that they would travel into space on a commercial flight if they could afford it. At an alpha, I like to put my alpha up here. At a level of significance, or alpha, of 0.01, is there enough evidence to reject the research center's claim? Complete parts A through C below. Let's just go ahead and solve this in its entirety, and then we'll go in and answer the questions, right? Okay, so in order to plug this into the calculator, calculator's not going to ask for a p-hat. In fact, calculator's going to give me a p-hat. What the calculator wants is the x value. So it wants to know, well, what is 28% of a 800? Also keep in mind, p-hat is x over n. So when in doubt, just plug in the two values that you know to find the one that you don't, and then solve accordingly. Or you can just say, okay, intuitively, if I want to know how many people believe that, I know 28% of 800 people believe that, or have that opinion. So I would just do 28% of 800. So I would just plug in 0.28 times 800, right? It's 224. Oh, my calculator's running out of battery. Goodness. Okay, hopefully it'll last. We're almost done. We're on 56 out of 60. Okay, this is a proportion, right? So we're going to go stat, tests, and we use option 5, which is 1 prop z test, right? Because it's a proportion. Stat, tests, 1 prop z test. Okay, so the p-value associated with our hypotheses is 0.26. Our x value is 224. Our n is 800. And the symbol associated with our alternative hypothesis is not equal to. So it's going to spit out the standardized test statistic. It's going to give us the positive one, but we could just use the negative one as, over there, which is the 1.2896 blah, blah, blah. It's going to give us the p-value, which is what we really want. Although real quick, I guess I'll write the z because I think it asks for it, right? 1.29 if we go to 2 decimals. It gives us the p-value of 0.19717177261. And it does spit back out the p-hat for us, but we already knew that. So this is our p-value. we're going to compare it to our alpha. The p-value is greater than the alpha. So since the p-value is greater than the alpha, the rule is we fail to reject the null. That combined with the fact that our claim was, and what was our claim? Which one was it? Our claim was the null. That tells us that, again, so first of all, we said that we're failing to reject the null because the p-value is greater than the alpha, okay? Then we're failing to reject the null, and our claim was the null, so there's not enough evidence to reject the claim, right? Not enough evidence to reject the claim, right? We're either saying that there is or is not enough evidence to do what? Reject or fail to reject the claim. Or I'm sorry, reject or support the claim. Sorry about that. Reject or support. Right? Not enough evidence to reject the claim. Oh, I should specify at the 1% level of significance. Right? So now let's go through and let's fill in everything here, given that we just solved this problem in its entirety. All right, identify the claim in the scenario. We already did that. The claim is that 26% of adults in the country would travel into space on a commercial flight if they could afford it. Okay. Then they want us to tell them what's the null and what's the alternative. Well, we're using the null has an equal sign, the alternative has a not equal, and we're filling in 0.26. Okay. Then they want us to tell them, well, what was the standardized test statistic? So we did go ahead and write that down because they are asking for it. Because remember, if you're doing this by hand, you're finding the z so that you can then find the corresponding area, which is the p-value. What is that p-value? It's 0.197 if you go to 3 decimals, right? And then when we compare the p-value to the alpha, we fail to reject the null. We say that there is not enough evidence to reject the research center's claim, right? It either is or is not, and we either reject or support the claim, which is not always the null hypothesis, right? Which is why you have to do that first. Talk about whether you reject or fail to reject the null. And then in this, we're talking about the claim, which is not always the null, right? Okay. Right. Now we get into our R values. Right? Data below are the number of absences and the final grades of 9 randomly selected students from a stats class. Calculate the correlation coefficient R. X is going to be your L1. Final grade Y is going to be your L2. Plug it in like we did back at the beginning of the semester where you go to Stat Edit. Plug it into L1 and L2. Okay. And then you go Stat Calc, 1 var stats, and oh, I'm sorry. No, I'm thinking back to the beginning of the semester. No, we go to Stat Calc, and then we go all the way down to where is it? Oh. Just have a brain freeze. Oh, sorry, we're not calculating. Sorry about that. Scratch that, rewind. We're running a test. Going Stat Test. And then you go down all the way to F, a linear regression t-test. Sorry about that. All right, and you got to tell it what you're looking at, right? So you got to tell it it's an L1 and L2. You leave this stuff alone and you say calculate. So it wants to know the correlation coefficient R. So we have to scroll down to R and we have to round to the number of digits that it tells us to, negative 0.991. So again, you put them in by going stat, edit, like one edit, to put them into L1 and L2. And then you go stat tests, right? Stat tests, and then you go all the way down to F, which is linear regression t-test, right? And you're looking for R, which is the correlation coefficient.